Now, my next step is to simplify a little bit further before moving on to 2. So I'm just going to clean things up inside, and I get 27 over n squared. Okay, so this is f of xi times delta x. Okay, stage 2, we'll bring our sigma into the game. Now, the way sigmas work is you can distribute them. Uh, 27 over n squared. So there's actually a couple things I can do. So I'm going to put my I equals 1 up to n. Put that back in there. Just to emphasize my next step. So this 27 over n squared, that can move all the way out front. I can bring it out of the sum because this guy does not depend on my index I here in any way. So I can move that out. And then I get 3i cubed over n squared minus 2i. Okay. Now, I can distribute my sigma. Let's go a nice big square bracket here. Okay, you can distribute sigmas across differences if it suits your fancy, and it does suit my fancy. I am a fancy man. And finally, finally these constants can move out. So let's zoom in here. Which constants? This 2 can move out front here, and this 3n squared can move out here. Okay, these are properties of sums that I do not want to dwell on, but they are very useful. It allows us to isolate the sums that we know how to calculate. Okay, now this guy and this guy, we have formulas for those. What are those formulas? Here they are. The first one here is given by that formula right there. And then this guy here is given by that formula. So I can plug things in. Three over n squared. Now this is the n plus 1 over 2 all squared minus 2, and this was the n plus 1 over 2. Okay, simplify. Let's see what we can do. What can we do? What can we do? I think that we're going to move over here now. Let's do that square there. 3 over n squared dot n squared n plus 1 squared all over 4. And this 2 cancels with this 2. And I applied this square. Next. Got a cancellation, a boo, and a b. Working. Now I'm going to eventually take the limit of this as n goes to infinity. I should keep that in mind as I simplify here. So I think if I put the 1 over n squared here, let's go purple. If I put the 1 over n squared back in, that will suit my fancy. Quite nicely. There's obviously many ways to do this, but this is my choice here. Now I got an exponent upstairs and downstairs. I can bring that out like so, n plus 1 over n. The other next fraction can be written like this. Now, why am I doing this? This is my motivation for making this step here is, well, I'm going to be going n goes to infinity. I mean, taking a limit as n goes to infinity. So if I arrange it like this, that's going to make this limit much easier to evaluate. So that is my motivation for a lot of these steps here. All right. Now, let's see. I suppose I could have factored out an n plus 1 up here. That may have made things a bit easier. Probably not too much, though. Now, what did I do here? Let's just talk about it. I went n over n to get 1, and I got 1 over n to get this guy. FYI. And I did a similar maneuver here. All right, now I can move on to step 3. Because this is sigma f of xi delta x. So the last thing is to find the limit n goes to infinity of sigma f of xi delta x is the limit of this thing of, well, this thing, which is a little too painful to copy out, sorry. So I'm doing the limit of this guy as n goes to infinity. So what's happening? What is happening? Well, the way I've arranged it, I've made my life quite easy, okay? The only place n is appearing is here and here, and the limit in both cases is 0. So I get 27, bracket 3 over 4, 1 plus 0 squared minus 1 plus 0, close bracket. So what do you get? 27, 3 quarters minus 1, which is negative 27 over 4. So our integral ended up being negative. So I'll pause for a moment, let you catch up, and then we'll look at the graph of this situation. Negative. It's negative because, well, look at this function. Pause and copy this. So I'm going from 0 to 3. So my calculation I just did was, I have these two areas here, which are positive numbers. And the integral, the definite integral I just calculated, was giving me negative a1 plus a2. And we got minus 27 over 4. So, to emphasize, this integral is not necessarily the area between f of x and the x-axis on the interval AB. Okay, we can see from this example the area between f of x and the x-axis, that would be a1 plus a2. But the integral is something a little bit different. It's what's called a signed area, or maybe you want to say a net area. So it's not the same thing as area between f of x and the x-axis.